So let's say we've done the ANOVA now and we get the result here saying that the means are not equal. Well, what do we do? Right now, there's not much. It just tells us essentially that out of all the means that we've done on lab day, that we're seeing that something's not equal. So what we can do is we can start going back into our descriptive statistics, and specifically we can look at the mean and standard deviation, but the mean is the big one that we want. So I can create a variable. I'm just going to copy and paste this that I've already done before. But I can go ahead and create a new variable called statistics. And so based on our group data, so up here, this variable grouped, what I want to do is from the group data, I want to take a look at mass salicylic. So this column, I could use any column here if I wanted to. And I want you to output the mean. So if I run this, I don't get anything because I have to print it. So I'm going to print statistics. Hopefully I spell that right. Run this one, and we'll see that there's the mean for every one of the lab days. So this is telling us that the means are not equal. Here's the means themselves. And now we can visualize this. Maybe we can do a bar chart, or even better, we can do a scatter plot. But what would be more helpful than this as well is this plus the standard deviation. If I could plot this with the standard deviation, I might get a better idea of what's kind of getting out of control. So back up here, I want to copy this as well. So let's say this one. I'm going to do Control C. I'm going to do Control V. Let's create something different here. So we'll call this standard, and we'll do a capital D. And instead of the mass of salicylic mean, I want to do standard deviation, so STD. And I'm going to want to print that as well. So if I print statistics, I can either do another print standard dev underneath like this, or I can just do a comma in here and like this, and hopefully that will print out. It might be one column after the other. If I wanted to, I could do a something to get the two columns to print side by side. Oh, did I not? Oh, it's not defined because I changed it in here. I got to run all cells. I created this and then printed it, and I haven't run all cells. So I got to run all cells so it recognizes the variable. I didn't run it, so I ran this cell. I didn't run this cell, and so this one didn't exist at the time yet, even though it was printed in there, typed in there. All right, so now we can see we've got the two columns essentially of data based on lab day. Here's the mean, and here's the standard deviation. We do have a null value out of the 0. I think that's because there's only one, potentially one value out of that. I'm not sure. And so what would be useful then is to plot this data and see how this goes so we can try to figure out what means might be out of whack for a technical statistics term. So with our new information here, with the mean and the standard deviation, let's try plotting it. We'll do a scatter plot, and we'll use the standard deviation as the error bars to try to see if we can find anything that's going on. So the first thing that we need to do is we need to put in this. So we're going to import matplotlib so we can actually plot the stuff. We didn't have it before, and we're going to do that as PLT. So make sure that gets incorporated. And then what we're going to do is we've already got the two variables, statistics and standard deviation. And so I'm going to show you what I did it in AI. So I just copied everything. I'll do a video that actually shows you how I copy this stuff and get the information. But this essentially is what came out of it. So I'll just paste that there. So this is it. And if I were to just follow exactly what Copilot or ChatGPT is telling me, I can run this, and I'm going to tell you right now I'm going to get an error because I already ran it and tried it. But let's see if we can figure out why. So we're going to plot this, and it's giving me right here, it's telling me the mean here, and their standard deviation is going to be the Y error bars. So it wants to plot error bars about the mean that we've got, and we're going to plot the actual mean itself. The Y error bar is a standard deviation. So here's something that we need to pay attention to. This is the variable that I created up here. So there's standard deviation, but where is my variable statistics? It's nowhere in here. So what we're going to assume is that this mean is actually this mean right here, but it's statistics. We're going to copy this and we're going to replace mean with statistics in that code. So let's try that out. And we're going to put in, instead of mean here, I'm going to Control C, then Control V, and I'm going to do Control V here like this, like that. And let's try running this cell again and see if it works. And sure enough, it does. All right. So Copilot and ChatGPT, they can give us a lot of information and have it work. But what we can do is we can actually take that error code that I had and put that back into ChatGPT with the code, the rest of the code up here, and say what's going on. And eventually, if you do enough iterations, you'll be able to find the answer and fix the data. Remember, we're not trying to be data, we're trying to be data scientists. We're not trying to be coder, like Python coding experts from scratch. We can use AI to help us determine some of the stuff. Because what we care about is this. This is the data. The ANOVA was telling us here that there are means that are not equal. And so we can see there's a couple of things here. There's a few that are really, really good that are coming through, but there's one with really tight error bars. Here's one with no error bars. That's the one that we saw that had the null value. So there's no error bars on this. Most of the data looks to be kind of in spec, but then we start to see a few of them kind of coming off like this. So if we had a larger one, potentially, like for example, this one with no error bars, might not actually be the same as, say, this one or some of the others. But we might be able to start to see, okay, well, the error on here is massive, the error here is massive. Maybe there's something going on. But really, these ones with the huge error bars would actually be, they would be in line with everything. So something's going on. It could be this one with the tight error bars. There's potentially like very little overlap between this one and this one. So we could now start to do t-tests on the L and the H lab days if we wanted to. We could do it on A and see if that was the one that was the suspect. So now we can actually use it to kind of hone in and figure out what days specifically were an issue. As this doesn't tell us right off the bat, but it gives us a clue as to what we might be able to do.